Okay, so when you've got a function here, and we talked about this way back in pre-calc, when you have a function here, so say we've got a function that looks like that, we have these kind of nubbins, which is what I called them back in pre-calc. You got this point right here that it's not a maximum, where it's not like the highest value the function will reach, but if you focus in on just like this small area, it is the smallest, or it is the highest value it'll reach in this small area. And so rather than calling it a maximum, it's a maxima. So if you focus in on just this tiny block that the function reaches, it's the highest value the function reaches in this small block. And the same thing with this little nubbin down here. It's not the lowest value the function reaches because it goes way lower over here, but it is the lowest value the function reaches in this little block of the function. And so it's not a minimum, it's a minima. And so we've got these, this particular function has a maxima and a minima. And you could have a function that has all kinds of these. So you could have a function that does this kind of thing, where it does this whole kind of roller coaster-y thing, and then it maybe does that, where you could have a whole bunch of maximas and a whole bunch of minimas on this interval.
That kind of looks like the cosine or sine.
Yeah, it kind of does. It does look kind of sinusoidal, but like, I mean, you could have as many of these as you want to. I mean, this particular one would have 1, 2, 3, 4, 5, 6. This would be x to the 7th in there somewhere. It would just depend, or 7? 1, 2, 3, 4, 8. This would be x to the 8th in there somewhere. So I mean, you could have as many maxima or minimas as you want to in a function. So what we're going to talk about today is how you can find the maxima and minima in an easier way than I showed you back in pre-calculus. In pre-calculus, you went about it. Right. In pre-calculus, we went about it in kind of a more difficult way.
We used our calculators, didn't we?
Kind of, yeah. We did, and it got a little difficult, and it was a little rough. Today we're going to use the derivative to make it a little easier. So let's take a look at a few different functions here. Let's say I have a function that is, say f of x is equal to, let's do x squared plus 5x plus, sorry, I'm having a weird moment. 6. Oh, I know I can do that.
Yeah, when in doubt.
Just your homework is really, really short this time. So, well, not really short. There's 11 problems on it. And 2 of those problems you're only looking at a graph. So, okay. So, if I want to be able to find, so I want to find critical points. So critical points are these maxima or minima, or what could also be known as points of inflection. And points of inflection are these turning points in between them. We talked about those a little bit last week, points of inflection. So to find critical points, step number 1, you're going to find the first derivative. First derivative. So the first derivative of this function would be what? Great, so I'm going to do f prime of x is equal to, put your phone on silent please.
That's weird.
I agree, that is a weird ringtone.
My headphones are plugged in.
I know what you, I was making a joke. Okay, so step number 1, find the first derivative. Step number 2, you're going to solve that for 0. Solve equal to 0. Equal to 0. So I'm going to set this equal to 0, and I'm going to solve it. So x would be equal to negative 5 halves. Absolutely. Okay. So now I'm going to take negative 5 halves, or negative 2.5, if you prefer decimals. Negative 2.5. I'm going to substitute that back into my original function and get a y value back out of it. So most of you, I'm certain, probably would prefer negative 2.5. Whatever. So I'm going to put negative 2.5 or negative 5 halves back into my original function to get a y value back out. So this represents a point in space. So I'm going to put negative 5 halves as my x coordinate, and I'm going to substitute this back in to find a y coordinate to go with it. So I'm going to do that right now. Possibly. You're a step ahead of me here. So let's do negative 5 divided by 2, quantity squared, plus 5, oops, 5 times negative 5 divided by 2, plus 6. Negative 1/4? Unless I did that wrong.
Oh, no, that's right.
Okay.
I messed up when I tried to use the fractions in head.
Okay. So negative
'Cause I
1/4.
forgot that I changed everything forward.
Okay. So this is our critical point. And now we need to know if it's a maximum or a minimum, or a point of inflection. And so to do that, so let me write, I'm missing some steps here. Step number 3, sub into original to find y. Does it help if I give you guys these step-by-step things here? Do you guys use them at all?
Oh,
Yeah.
Okay.
It makes it, I don't know, because I look at my notes sometimes and I'm like, oh, I remember doing this, but I don't know where the first step is. Like, this really helps.
Point. So now you have this point, and now you need to know, is this point a minimum or maxima or a point of inflection? And here's the thing. So to do that, you're going to find the second derivative. Find the second derivative. This all sounds like a lot of work, but like once you start doing it, it's really not that bad. Right, so the second derivative is f double prime of x, which is just equal to 2. All right, now there's 3 possible cases here. So if f double prime of x is greater than 0, it's a minima. If f double prime of x is less than 0, meaning if you get a negative thing back out, then it's a maxima. And what's the third possible case? Right. If f double prime of x is equal to 0, it's a point of inflection. There you go.
So,
Yeah.
I guess, why did,
So then this point right here, like this point that we found, this is a minima. Now there's going to be some where you might have 2 points that you need to find, and you need to know if one of them is a minima or a maxima, or if one of them is a point of inflection. And so you would need to find the second derivative and substitute the x value into the second derivative. If you get something out that's positive, then that point was a minima. Something out that's negative, that point's a maxima. If you get back out 0, it's a point of inflection. So let's do part of the assignment together so I can show you what that means.
I guess, I don't know, could you just like skip right to finding out whether it's a maxima or minima and then go in and solve for that point?
Sure.
Okay.
So your assignment today is page 139, 1 through 12, not 7. So let's take a look at that. So go ahead and grab one of the books back there. There's only 4 in the room right now, so I'm assuming that 2 of them are out there somewhere.
I've got one. I got one.
Okay, that's fine. I mean, I don't mind. I just wanted to make sure that they were somewhere. So
Skip 7? Was that?
yeah, skip 7. It has natural log, which I gave you a rule for doing the derivative of natural log, but it hasn't shown up on any of your homeworks. So
Isn't it just e to x?
no, that's for e.
Oh, the natural log rule. Wow.
Yeah, it's in. I gave you like the rule for it. It hasn't shown up on any of your homeworks. So I didn't think it was fair for it to show up now since I haven't used it. So I'm gonna gradually reintroduce it.
Natural log rule.
Yeah, it should be in your notes.
Yeah, that's that 1 equals 1 over x.
Kinda. It's kind of the chain rule. It's okay. We'll talk about it. We don't need to
That's
do
what
it.
you have right in your notes. Is it?
I know.
1 over x.
We'll talk about it though. All right. So we're looking at. Okay. This is page 139. Let me zoom in some more. So looking at this here, yeah. So find the critical points of the function shown and identify them as local max, local min, or neither. So question number 1 and number 2, you're just identifying it from the graph. So on question number 1, looking here, your local maximums would be, let's see, what tools can I use? Can I mark this up with my mouse?
3.
So 3 would be a local max. Where else would a local max be?
5.
5 would be a local max.
9 and 4.
I would just put it down as 9. I mean, I would say they all fall. I mean, it looks like it's a little higher than 9, but if you said 9, I'd be fine with it. And then I would also say a max would be at 13, because it's the end. So the maxes, I would say, would be 3. Even though it looks like it's a little bit less than 3, I'd say 3 is fine.
3, 5, 9.
3, 5, 9, and then 13. And then the minima would be where? 1. Where else? 4. 7. 10. It's a little higher than 10, but 11 seems like it's a bit too high. So I put 10. And then number 2 is pretty much the same thing, right? So let's take a look at number 3 here then. Oops. Going too far. Okay. So number 3. So step number 1 that I asked you guys to do was to first find the first derivative, right? 2x plus 8. So for number 3, the first derivative is 2x plus 8. And then set this equal to 0. So equal 0. And now solve this for x.
X equals -4.
Okay. X equals -4. Cool. So find the first derivative, set it equal to 0, and once you solve that, what do you do with this x equals negative? Plug it back into the original. -9. So our point here of interest is -4, -9. Now, we need to be able to tell, is this a minimum, is it a maximum, or is it a point of inflection? So now we're going to find the second derivative of the function. So f double prime of x is 2. Is that less than 0, greater than 0, or equal to 0?
Greater than 0.
If it's greater than 0, is it a minimum or maximum or a point of inflection? It's a minimum. So this is our critical point, and it's a minimum. No messing around with the calculator required, and we have the exact point.
So is there going to be more than one on these? Okay.
In fact, there's more than one on number 5.
So what, do you find like the,
Let's do number 5 right now.
yeah.
So let's jump ahead to number 5 if you guys don't mind. So looking at question number 5 here. So the first step is to find f prime of x. 3x squared minus 12x. So step number 1, we found the first derivative. Step number 2, we set it equal to 0. So to solve this for x, the first thing we should do is factor out any like terms between the two. Not just an x,
3x.
3x. And then what's left behind between the two of them would be,
So 4 and 0.
right, so we've got 2 points here, x equals 0 and x equals 4. Now we'll have to substitute both of these back into the original function, and we'll get 2 points back this time.
0, 0.
So if I put 0 back in to this original function, I don't get back out 0.
Five.
I get back out 5. And if I put 4 back into the original function, I get 64, 6 times 16 is 96. 64 minus 96 is -32. Plus 5.
-27.
somebody might want to check my math. I'm afraid.
No, I'm pretty sure that's right.
Okay. So here are our 2 points, and now we need to check to see if these are right. So now here's the next step. So bear with me here. So we found the first derivative, we solved for 0, we substituted them back into the original equation. Now we find the second derivative. So f double prime of x.
X minus 12.
Okay. Now, there's still an x in here. So what we have to do is evaluate it at 0 and evaluate it at 4. So if we put 0 in, this becomes,
Negative 12.
now, negative 12, is that greater than 0, less than 0, 0, or equal to? So this one here is a maxima. Okay? Now if I put 4 in, which is the x coordinate from this one, 12, which is greater than 0. So this one is a minimum. Now if I got that either of them were equal to 0, it would have been a point of inflection.
So if it would have been, if one of them would have been 2, it would have been a point.
No, if one of them would have been, oh yeah. If either of the x values was equal, yes. I see what you're saying. Kind of, sort of?
Yeah. I have a question on 2.
Mm-hmm.
So, would the
Are you asking about 3?
Yeah.
It's not a maximum.
Not a maximum?
It's also not a minimum. Because it's, so like, the maximas on 2 would be 0,
5 and 11?
5, and 11, yeah. And then the minimas would be 2, what is that, 8?
2, 8, 15.
Yep.
So, would 3 be one of those points in inflection?
Mm-hmm. Yep. Because it's not like, there's no nubbin at 3. There's no peak there. Instead, it's just a break almost, but there's no peak. That's why it's not a maxima.
I seriously feel like we did something like this last, like, I don't know.
We did.
Well, yeah, I know, but I don't know.
We did like, you were finding minimas and maximas last year, yeah.
But I feel like doing it like this. Did we find it?
Not using derivatives, but like, here, if I load up, I'll show you even last year's.
Like, I remember doing it last year on the calculator. Like,
Mhm.
I remember the trace function, but I don't know. Maybe it's all just making sense, and I just think I don't know.
Here, look, let me show you. Today is October 17th. This is last year's warm-ups. This is October 19th of last year. This is your warm-up from October 19th last year.
Hey.
So, yeah, you did something just like this last year. This exact same time. Alright, so you guys should be fine to do the rest of this. If you need help, please let me know. I'll come around to help anybody. 7 was the only one I thought you might need help on. On 9, 10, 11, and 12, disregard the on the entire number line part. They're throwing something extra in that they don't need to. So
So, do you have to factor out 6 before you can solve?
I did, and I thought it made it easier. You can either do that, or you can use the chain rule and the product rule together, which I thought made it more difficult. So what I did for number 6 is I FOILed that first part out and then multiplied it by x minus 3, and I thought it made it easier. You don't have to, but that's what I did to make it easier. But you usually like things to be easier? It's either that or use the chain rule and the product rule.
No, I don't really know how to use those.
3 points, and it would be 1, 1,
Which one has 3 points?
6.
No, it doesn't.
Doesn't?
It has 2. The most they have is 2. Number 6 has 2 points. The 2 points are
1 and 3.
no 1 7/3. Use you.
Isn't doing it well. I was guessing.
Okay, then no, I'm not going to look at your work. You're just trying to get work from me. Maybe.
Do you have the answers, Mr. Pastor?
Yeah.
If my number 4 is right?
I don't know where you got it either.
Oh, that's the name of that movie, Hocus Pocus.
I appreciate you trying to use mental math, though.
Me?
Mm-hmm.
Eighteen minus 36, negative 18.
Mm-hmm. Plus 7.
That's negative 11.
There you go.